The James Webb Space Telescope is a next-generation observatory on a mission to study the origins of the universe. Despite the unexpected impact to one of Webb's mirrors, NASA says the spacecraft is fine and will release its first science-quality images. What will the James Webb Telescope reveal, and how will it help in further explorations? If you're wondering the same, welcome to Space Discoveries, and in today's video we're going to take a look at the current status of the James Webb Telescope and the revelations it will make. Curious? Let's get into it. 6 months after the launch of astronomy's new Super Space Telescope, NASA is finally ready to release the first real-color images from the James Webb Observatory. One of the primary mirror segments of NASA's James Webb Space Telescope was damaged. In a statement, he stated that the impact was caused by a micrometeorite, which NASA predicted would occur during the telescope's orbit around the Sun. The agency defines micrometeorites as dust-sized particles flying at high speeds. Webb's golden mirrors were designed to handle these particles, but this micrometeorite was larger than expected. According to NASA, he said it will be a once-in-a-lifetime opportunity for everyone to pause and marvel at a view of what humanity has never seen before. The US Space Agency, which oversees the Webb project, previously released a set of engineering images demonstrating that all of the hardware on the $10 billion telescope is operational. The dust-sized space rock was causing a noticeable effect in data from the $10 billion telescope, but it was not expected to limit the mission's performance. Webb's image clearly shows not only the foreground stars, but also more subtle details such as wispy clouds of interstellar gas and hundreds of background stars and galaxies. An IR cam, an infrared imager that ranges from visible to near infrared, is one of the instruments aboard the James Webb Space Telescope. The NIR spec will conduct spectroscopy in the same wavelength range. MIRI will measure wavelengths ranging from 5 to 27 micrometers in the mid to long infrared range. Those images showed slightly different views of the Large Magellanic Cloud, a small satellite galaxy of the Milky Way, but it's unclear what the first full-color images will show. Webb has been calibrating instruments and aligning mirrors for 6 months in preparation for science work. It was launched into space on December 25, 2021, and eventually settled into orbit 1 million miles from Earth. Scientists hope that the observatory, which will replace the Hubble telescope, will be able to travel back in time 13.5 billion years to within 100 to 200 million years of the Big Bang. Its ambitious mission is to investigate the early universe, determine how fast it is currently expanding, and examine objects ranging from galaxies to exoplanets. The famous golden mirror of the telescope is made up of 18 individual hexagonal segments, each of which is controlled by 7 actuators for precise movement and focus. They had to be slowly and meticulously deployed over the last 6 months to prepare James Webb for its science mission. As we near the end of preparing the observatory for science, are on the verge of an incredibly exciting period of discovery about our universe, said Eric Smith, a Webb program scientist at NASA's headquarters in Washington. These images will be the culmination of decades of hard work, talent, and dreams. Methane may be a more reliable indicator of alien life than oxygen, as the James Webb Space Telescope prepares to begin searching for biosignatures on other planets. Hubble discovers a mysterious object from the beginning of time, which is a supermassive black hole ancestor born shortly after the Big Bang. According to NASA, Webb is now at full power and ready to begin its science mission. It took more than 5 years to figure out what the telescope should look at first. NASA, the European Space Agency, the Canadian Space Agency, and the Space Telescope Science Institute in Baltimore, which is home to Webb's science and mission operations, were all required to work together on this project as part of an international collaboration. According to an astronomer named Klaus Pontoppidan, who works as a Webb project scientist at STSCL, said that the goals of Webb's first images and data are to showcase the telescope's powerful instruments while also providing a preview of the upcoming science mission. After the science and engineering teams behind Webb have finished calibrating, testing, and giving the instruments the all-clear, the spacecraft will begin taking its first images and conducting its first spectroscopic observations. The diameter of the primary mirror that was designed by James Webb is 21 feet 4 inches, and it is constructed of 18 hexagonal segments of gold-plated beryllium metal. The large primary mirror is held up by 3 shorter carbon fiber tubes, also known as struts, which extend outward from the mirror. The group will run through a list of pre-selected targets before beginning the process of processing the images for public consumption. NASA has stated that, because the new telescope is so powerful, it is difficult to predict exactly how Webb's first real images will look. This is despite the fact that careful planning for Webb's first real images has been going on for quite some time. Of course, there are things we're expecting and hoping to see, but with a new telescope and this new high-resolution infrared data, we'll just have to wait and see. The new images, which will be the first to be captured by Webb in full color, will showcase the spacecraft's comprehensive scientific capabilities. In addition to capturing imagery, the Webb telescope will collect spectroscopic data, which is detailed information that astronomers can read in light. All of that data is gathered during the process of aligning the telescope, and preparing the instruments will be made public. After the observatory has finished acquiring its initial set of images, it will start conducting scientific observations, which will make it possible for the primary scientific questions raised by the mission to be investigated further. A competitive application process has already been used by teams in order to request time to use the telescope during its first cycle, also known as its first year of observations. These observations mark the official beginning of general science operations for the Webb Space Telescope, which is the work for which it was designed. In addition to the things that have already been planned for Webb, there will be surprising discoveries that astronomers are unable to predict. In 1990, when Hubble was first put into orbit, nobody had any idea what dark energy was. It has quickly become recognized as one of the most fascinating subfields of astrophysics. Scientists are currently waiting to find out what secrets James Webb will reveal, and what the implications of these revelations will be for our current understanding of the universe. Webb, which NASA describes as the premier space science observatory of the next decade, will primarily observe the cosmos in the infrared spectrum. This will enable it to peer through clouds of gas and dust where stars are born. Because Webb is roughly 100 times more powerful than Hubble, it is able to observe objects at greater distances, and as a result, further back in time than Hubble or any other telescope. Hubble and the James Webb Space Telescope will continue to collaborate for some time to come. NASA prefers to think of James Webb as Hubble's successor rather than Hubble's replacement. James Webb's development began in 1966, and its launch was originally scheduled for 2007. However, in 2005, the mission underwent a significant redesign, which pushed back the launch date. After a number of additional delays, the mission was finally successful in entering orbit at the end of 2017. The James Webb Telescope has been compared to a time machine that has the potential to solve the mysteries that surround our universes. The telescope will be used to look back in time more than 13.5 billion years to observe the birthplaces of stars, exoplanets, and even the moons, and planets that are part of our solar system. The James Webb Telescope and the majority of its instruments run at temperatures of approximately 40 Kelvin, which is equivalent to approximately minus 387 degrees Fahrenheit. It is the world's largest and most powerful orbiting space telescope, with the ability to look back between 100 and 200 million years after the Big Bang. Still watching? We knew you'd love our video. Well, we'd be even happier if you could just hit that like button. And with that being said, it's time to end our video. After considering the advantages of James Webb Space Telescope and its first science-quality images, do you think that James Webb Space Telescope is Hubble's successor rather than a replacement? Let us know in the comments, and make sure to subscribe to the channel for more amazing videos like this. And now that we know you love our videos, make sure to watch these as well. We'll see you in the next video.